In this video, we are going to discuss what elements to consider when you are preparing for your experiment. As a reminder, to illustrate this, we are considering alumni donations. We already have some data. We have the contributions received by a college from alumni in 2004. The population are the groups of alumni who graduated in 1957, 67, 77, 87, and 97. We also know some of their previous donations, and we know if they attended an event. The question we have is how we use these data to determine whether hosting events for an alumni is worth the expense, and is there anything more we can do to answer this question. Here are a series of questions you should ask yourself before starting any analytics project or experimental project. First, the main question is, what business decision am I considering? Then you should ask yourself, what information would help me make that decision? And can I get that information reliably from the data I already have? Otherwise, should I collect new data? If so, what kind of data, and how to collect it, and how to analyze it? In our specific case, the question we are wondering about is, should we increase or reduce the number of events for alumni? What information would help me make that decision? Well, does attendance at events increase donation in a causal way? Can I get that information reliably from the data I already have? Probably not, because it's observational data, so I cannot make any causal inference. So, should I collect new data? Well, yes. And how should I collect it and what kind of data is what we are discussing in this course. So everything we are going to talk about today is going to help you answer the following question. How do we design an experiment to test whether attending events increases an alumni's chances of donating? And this, we would want to answer it in a causal way, not just find an association. How to design an experiment is a very important question, and you have researchers dedicating their whole career to answering it. If you have a well-designed experiment, the analysis is very easy because the data helps you directly to answer the question. The problem is that finding how to design this experiment well is the part that is difficult. If it's not well designed, you end up creating a lot of the same problems that you can find in observational data. The list of things to consider when you are designing your experiment is quite long, and I have put just a few important factors here. First, you have the outcome variables. Which one do you want to measure? For instance, if you run an ad campaign, do you want to measure the number of clicks? Or maybe the number of pages visited? Or maybe the change in sales? So which one would be better to measure to answer your business question? Then you might consider the observational window. If you run an ad campaign, for how long are you going to wait to see the results? An hour? A day? A week? Then you should consider the feasibility. So can you reliably get the participants that you want to recruit? Can you apply the treatment effectively? Can you measure the variables of interest, including specifically the outcomes? For instance, some ad platforms might not allow you to randomize effectively or to target individuals with precision. Then you have to consider the cost. How much will it cost? Can you afford it? And is running the experiment even worth it? For instance, you won't fully develop two different products just to test which one will sell better. It is very costly to develop and manufacture products at a large scale. So this is not even an experiment worth running. Then you have to consider how much data to collect. Is a small sample sufficient? Can you run it in just one of your stores, or do you have to run it in several stores? You have to consider potential confounds. For instance, if you run your experiment in some stores, are there other variables associated with these stores that might affect the outcome? And in the same fashion, you can consider collinearities. This could prevent you from accurately detecting or measuring the magnitude of an effect. Then you have to consider order effects. For instance, could running one version of an ad first and then a second version produce a different result than if you ran the second version first and the first version after? Then you have seasonal effect. For instance, you run a discount randomly on some days and no discount randomly on some other days. Could there be seasonal effect? Like for instance, the discounted days fell on a weekend, so that might affect the outcome. Finally, you can consider market effects. For instance, if you run a discount, your competitor might also start offering a discount, so it would change the structure of the demand. So the experiment you run might actually affect the whole structure of a market. Among all the factors and questions you have to consider when you're designing your experiment, you can classify them in broadly two categories. Some of it is more of an art, like which treatment to apply, what is your X variable, and what response to measure, so what's the Y variable, how to model it, and how to control for other potential factors, so the other X's that are not part of the treatment or the variables that you're not observing, the Z's. And you have the science side, so how many observations do you need to reliably detect an effect? Which combination of factors to apply and measure? What are the treatment causing the different outcome? So all of these, it's part of statistics and you can answer it by doing some math. I want to conclude this video with a quote by Ernest Rutherford saying that if your result needs a statistician, then you should design a better experiment. So according to Rutherford, most of the difficulty is to design a proper experiment. Now, there is an important note to add. To design a good experiment, you might actually need a statistician.